All right, so this is 5.2. We're verifying trig identities today. We're proving, all right? You guys are going to be given a statement that is a true statement, and you have to go through all the steps to prove it. Hopefully, things will start to come back together. I understand it's a little difficult. I get it, but if you just guys keep working and don't give up, that's really important. You should have your identities. Screenshot them, put them on next to each example that we do so you can look at it. But here are some tips. Right? Now, again, I can't just say that you do the same thing every time. It doesn't work like that with this stuff. But there are some things that you can try and do. First thing it says is to work with one side of the equation at a time. You'll see what I mean by that in a second. But pick a side. Usually we like to pick the one that looks a little more complicated to simplify it. But if you don't want to get yourself lost, so you want to have a method that you kind of go with every time to start. You want to look for opportunities to factor, to add fractions together, to square a binomial, or to create a monomial denominator. You want to simplify. If you have a denominator, you want to try and get rid of it. If you have a denominator that has a plus sign, you want to try and get rid of it so it's only one term in the denominator, something like that. You want to try and use your fundamental identities. And you want to stay organized. Your most basic trig functions, guys, are sine and cosine. So if you want to always try to get things to sine and cosine, that's fine. Yesterday with A period, there was two people. They were doing a wonderful job, but they saw things differently than I did. It's fine. There's not just one specific route you have to take. If you want to convert everything to sine and cosine first and then go that direction, fine. If you want to try and go to fundamental identities first, your Pythagorean identities, and then convert, fine. As long as mathematically it makes sense, that's an okay answer. So just because I see something, you might sit here and go, wait, I could have gone this route. That's fine, as long as it makes sense. But always, 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 guys, try something. Even the book says, even making an attempt that leads to a dead end could provide you some insight. So let's look at this, all right? This is what this is going to look like. You're verifying the identity. They gave you this example, and they said secant squared minus 1 divided by secant squared equals sine squared. That is a true statement. So you are going to go through the mathematic proof to show me why those two things are equivalent, why they're the same. Okay? These problems, you might have 4 or 5 steps. You shouldn't have more than that. If you do, then you kind of went the long way, which again is okay. But you shouldn't have more than, I'd say, 4 or 5 steps. First thing you should do is what? Okay, we're going to try and simplify, but what's the first thing that you should have right next to you? Your chart. You should have your identities right next to you. Every single example that I do, every single problem that I do, I put the chart right next to me. I know the chart because I've been doing this a long time, but I still have it there just in case. Helps me just kind of look. Now, the second thing we're going to do is we're going to set up a 2-column proof. I know. Just like when we were in geometry, we're going to set up a 2-column proof. Now, again, everybody does things differently. This is how I do it. I look at this and I say, which side looks more complicated? The left-hand side or the right-hand side? The left, correct? The right-hand side is pretty simplified. There's really nothing else we could do there. So I'm going to leave the right-hand side alone. I want to go through mathematical steps, problem-solving thinking, my identities, to show that the left-hand side is the same as the right-hand side. So we're going to talk through this, guys. Do you see how in the numerator, there's a secant squared theta minus 1? Yeah? I told you, whenever you see a trig function squared and it's attached to a plus or minus 1, where should we look? To our Pythagorean identities. So I'm going to look down here. Do you see something that has secant squared? Yeah. And do you see can I do something with this identity to make it say secant squared minus 1? I could subtract 1 from both sides, right? If I subtracted 1 from both sides, I can turn this into tangent squared theta equals secant squared theta minus 1. Do you guys agree with that? Okay, so look, the first step, all I'm going to do is I'm going to change the numerator here to tangent squared theta over secant squared theta. Everybody see how we did that? Right? Pretty simple step. Now, already this looks simpler, right? You want to get rid of any plus or minus ones and stuff because now we can just kind of convert. What are our two most basic trig functions? Sine and cosine. Agreed. Totally agree. I want to try and prove that the left-hand side equals sine squared. So can I do something? Can I change tangent squared into sine and cosines? Okay, what can I change tangent squared to? Sine squared over what? Cosine squared. Everybody with me? All right, I still have my division, my fraction bar, right? Can I change secant squared into something that has sines and cosines? 1 over cosine. Okay, agreed. I can change the secant to 1 over cosine squared theta. Now, it may not seem like we're getting anywhere, but we really are. We want to try and simplify to sine squared theta. The left-hand side equals the right-hand side. We already know that from the beginning. We're just proving it. Can you do keep, change, flip? Very good. Because think about it, guys. I've told you a million times, we have to think algebraically. This is just a fraction divided by a fraction. So you keep, change, flip. Watch what happens. You keep sine squared theta over cosine squared theta, right? You change division to, and I flip. 1 over cosine squared becomes cosine squared over 1. And what do you notice happens? Your cosines cancel, and you're left with what? Sine squared theta equals what? Sine squared theta. And that, ladies and gentlemen, is you verifying the trig identity. Do you see how it only took us about 3 or 4 steps? Right? We're not going to get into any that take you 10 and 15 steps. It's just not going to happen. Hang on one second. One thing I do want you to understand is I am going to check everyone's work. You can't just write down a bunch of nonsense like identities and do a little squiggly line like this and write, yeah, it works. Like I will actually check it, so don't do that. Question. Right? I know how to get you to think in the direction that I'm trying to get. The first step is usually the hardest. So let's work, okay? Let's look at the next one. Kind of survey the situation. See what we're looking at. Remember, we're always going to think algebraically. Think algebraically. So I look here, and it says verify the identity. Again, they're telling me I already know the left-hand side equals the right-hand side. Which side looks more difficult? The right. Okay, so let's simplify that one. What do you notice about the right-hand side? It has one, it's got a fraction, right? We know how to add fractions, don't we? If I had to add 1/2 and 1/3, you'd get a common what? You'd get a common denominator. Same thing for this. If you guys don't like the little alpha symbol, if you want to change it to x or theta, that's fine, I don't care. Sometimes in the middle of a problem I change, and I don't mean to. I just, whatever. But what's a common denominator going to be between 1 minus the sine of theta, or alpha, and 1 plus the sine of alpha? What would I do with those two? If I had a common denominator, if I needed a common denominator between 1 and 3, what would I do? I'd multiply them together. I'd get 2 times 3 is 6, right? So I'm just going to multiply them together. I'm just going to rewrite them on the bottom. 1 minus the sine of alpha and 1 plus the sine of alpha. Right? You're allowed to do that. How do you get a common denominator to then become equivalent fractions? What you do to the bottom, you do where? If I multiplied the bottom here by 1 plus sine alpha, I have to multiply it where? Okay, agreed. 1 plus the sine of alpha. Okay. So I have 1 plus sine alpha. Now over here, I multiplied the bottom by what? 1 minus sine alpha. So what I do to the bottom, I do where? Perfect. So I have plus 1 minus sine of alpha. All right, we're not yet to 2 secant squared alpha, but we're getting there. Okay, let's simplify. Let's think algebraically, guys. Look at your numerator. Do you have anything in the numerator now you can combine? Okay, I have a positive sign and a negative sign, so what happens? They cancel. Good. I have ones. How many of them do I have? I have 2. Well, isn't that pretty? Right? I think these are a little easier because it kind of gives you something to as a guide. Like you know where you're trying to go. We're trying to get to 2 secant squared alpha. Does it already look like we're in the right track? Yeah. Now, what do I do with the bottom? I have 2 binomials. What do I do with those 2? I FOIL it. Perfect. So 1 times 1 is 1. 1 times sine of alpha is positive sine alpha. Negative sine alpha times 1 is negative sine alpha. And what's sine times sine? Negative sine squared alpha. Good. That looks like a 2. Okay, can I combine anything? Negative sign and a positive sign cancel, correct? So I'm left with, on the bottom, 1 minus sine squared alpha. So you guys are like, oh, where do I go from here? Well, think about that. You have a sine squared. You have a trig function squared with a 1 attached to it, with a plus or minus, right? So where should we look? Where should our eyes go? To our trig identities. Is there a trig identity, a Pythagorean identity, that has a sine squared and somehow I can have it have a minus 1 on it? Or a 1 minus? The top one, right? If I subtract sine squared from both sides, do you guys agree that this gives me cosine squared alpha equals 1 minus? You're going to use that identity a lot. So I'm going to now replace this 1 minus sine squared with what? Cosine squared alpha, okay? Now remember, when we're super simplified, we don't have denominators, right? Do I have something over cosine squared? Can I change that into something? Say it again. Perfect. Right? 1 over cosine is secant, correct? So 2 over cosine squared is just going to give me 2 secant squared alpha, which, isn't that what we were trying to get to? So you guys just proved it. Again, I'm going to check your work. You can't just write a bunch of identities down and be like, check mark. Okay, how did I get from 2 cosine squared alpha to 2 secant? Do you agree with me right here with this trig function, right? 1 over cosine equals secant, right? So if it's squared, then this is just squared. If it's a 2, then it becomes 2. You know the numerator. If it's a 7, then it becomes a 7. That's fine. Yes, sir.
I don't understand how you went from this to...
All right, we got our. You understand where we got our common denominator from, right?
Yeah, because we had to multiply.
Correct. So when we multiplied, we got 1. This was the sine of alpha, positive. This was negative sine of alpha, right? So if I have a positive something and a negative something, they cancel out. And then I had a 1 here, and I had a 1 here. So 1 plus 1 is 2.
Okay.
Yep. Good. All right, we're going to do 2 more. How does this one look? Harder or easier? Or they all just look the same? They all just look terrible, right? That's like my voice. Okay, so the first thing we're going to do is we put our trig functions, our identities, our chart, we put it there so we can see it. Excuse me, and we're going to make our 2 columns. Which side, ladies and gents, looks a little more difficult? The left-hand side. I agree. Looks a little messy, which is fine. But what is something that you notice about the left-hand side? It's in parentheses, okay. What else do you notice about it? It's got squared and what else? It's got a plus or minus 1. So where should your brain look? At your Pythagorean what? Identity. So tangent squared plus 1. Look at your Pythagorean identities. Is there a Pythagorean identity that has a tangent squared and a positive 1? What does it equal? Secant squared. So I'm going to just replace this parenthesis with secant squared of x. Everybody see that? Okay. And I'm going to multiply this, and we're going to come back to this identity a lot. Do you see an identity in your Pythagorean identities that has a cosine squared and a plus or minus 1? The first one. We're going to come to this one a lot. What would I have to do in order for this first identity to become cosine squared minus 1? You're going to subtract cosine from both sides, right? If I subtract cosine from both sides, is that you, Ralph, in that? Good, very good. 1 minus cosine. Agreed? So I'm going to replace this whole cosine squared minus 1 with just the basic trig function of sine squared of x. Yep.
If cosine's not negative in the...
Oh, yes, you're right, I'm sorry.
But even negative...
Okay, you're right. Hang on, let me go back for a sec. Okay, so you have sine squared plus cosine squared equals 1, right?
Yeah.
We want this to say 1, or cosine squared minus 1, not the opposite way, correct? So it's one little extra step. We're gonna subtract the 1 from both sides. Yeah, to get sine squared x equals, yeah, negative sine cosine squared x minus 1, right? So this would be negative. Good catch. Okay, so we're trying to get to negative tangent squared. All right, we can do it. What are our most basic trig functions, guys? Sine and cosine. Can I change secant squared to something in terms of sine and cosine? 1 over cosine squared, I agree. So 1 over cosine squared x. Do I need to do anything with the sign? No, it's already pretty basic. We can just leave it. So negative sine squared x over 1. These are just fractions that we're multiplying, right? Multiply the numerators. You get 1 times negative sine x squared is negative sine squared x. Cosine squared x times 1 is just positive cosine squared x, right? All right, that's pretty simplified, but it's a fraction. Can I change sine squared over cosine squared into one trig function? And what kind of a tangent is it? It's negative tangent squared x, which, guys, is what we were trying to prove, correct? Equals negative tangent squared x. Good. Your answer is not negative tangent squared x equals negative tangent squared x. This is your answer. All of the meat that got you from point A to point Z. Yes, ma'am. Explain that. How did the sign become negative? I started off with the, our basic Pythagorean identity. Sine squared x plus cosine squared x equals 1, right? We want to rearrange that formula so it says cosine squared x minus 1 up here, right? So in order to do that, I'd have to subtract the 1 from both sides, which would give me sine squared x plus cosine squared x minus 1 equals 0, right? You agree with me? You see that? Now, I want it to just say cosine squared x minus 1. I don't want that sign there. So how would I move the sign to the other side? I'd subtract it, right? So now it says cosine squared x minus 1 equals negative sine squared x. Does that make sense? Okay, good. Yeah, I didn't explain it very well the first time. All right, let's do one more, and then I'll let you guys work on your web assignment, and we'll finish up tomorrow. First thing I need to do is get my identities. Put them right here next to me. Again, you will have these on your test or quiz. I'll put it over here. All right, now they're telling you to convert to sines and cosines. again, on your test or quiz, it's not going to tell you what direction you should take. But we go through the thought process and we think, okay, if there's a Pythagorean identity, if there's a trig function squared with a plus or minus 0, I want to look there. If there's a denominator, I want to get rid of it. Then once we're all linear, we're on the same level, we don't have any squares or anything like that, now you could say, okay, let's just go to sines and cosines. Now, I think both sides look fairly difficulty-wise the same. But which side, if you had to pick one, is harder? I agree with you. Why? Because there's a plus sign. I totally agree with you. Now, if you started on the right, that doesn't mean that you wouldn't get the right answer. Some of you might see things differently, and I told you that. That's okay. That is okay. But let's try to go to sines and cosines. That might be the easiest thing to do. So can I write tangent in terms of sine and cosine? Sine over cosine? Okay. Sine x over cosine x. Agreed. Plus, can I write cotangent in terms of sine and cosine? Cosine x over sine x. Now, some of you say, oh, can I just cross out the cosines and the sines since one's on top, one's on the bottom? No. If we were multiplying, you absolutely could. But we're not, are we? What are we doing? Adding. Guys, when you add fractions, you have to get a common denominator, okay? Just like we would in elementary school. What is a common denominator between cosine and sine? You multiply them together. Perfect. So I have cosine x times the sine of x. You just stick them together. Just like we would if we had 3 and 5. We'd stick them together. 3 times 5 is 15. So guys, to get a common denominator, what you do to the bottom, you do where? Perfect. It's already sounding better. This one has a cosine, so it needs a sine. If I multiply the bottom by sine, then I multiply the top by sine. So sine times sine gives me sine squared x. Perfect. Plus, the second fraction has a sign. What's it missing? So if I multiply the bottom by cosine, then I multiply the top by cosine. What's cosine times cosine? Cosine squared x. All right. So you might be thinking, oh, geez, that really didn't help us any. Look at your Pythagorean identities. Is there a value that I can replace sine squared plus cosine squared with?
1.
Correct. Sine squared plus cosine squared equals what? 1. So this is 1 over cosine x times sine x. Now you guys are like, wait, huh? Hold on. I'm still trying to get to secant x, cosecant x. Question.
How did you get, how did it become a 1 though?
Because sine squared plus cosine squared equals 1. That's your identity.
So then you just split up.
Now we can do what, Raul? You could just split them up, he said. Of course. I can say 1 over cosine x, good, times 1 over sine of x. Right? If we're simplifying, we do not want fractions in our answer. Is there a way that I can rewrite 1 over cosine?
Yes.
I can write it as secant of x? Okay. Is there a way I can write 1 over sine? I can write it as cosecant of x. Guys, what did you just do? You verified it. You proved. Raul, great job. Come here. Yeah, that's not fun. Don't laugh. Okay, so tomorrow I'll finish the last 2. But tonight for your WebAssign, I suggest you start it. And again, the first step is always the hardest. So you guys got to just do your best. I will extend your 5.1 due date until Friday morning, so you guys have a little more time. But all you need to do is use your WebAssign for 5.2, just the questions. That's all you need. Take a picture of them, turn it into a PDF, whatever. Do not enter any answers on WebAssign. It's very confusing to try and do this on WebAssign. So just take a picture of each question and do a 2-column proof, just like we did on a Notability PDF, and submit it. Good? Go ahead and open it now so you have some time. So let's look at it. If you have any questions, I'm here to help. But try.